This one's 7B83. It's line 22. RF tailored voltage waveforms, argon gas formula, 5G Wow Seti. There's the alien radio signal, and there's the data there. So this video is going to be about RF high frequency, argon gas, tailored voltage waveforms, formula, excited plasmas, ion flux density, distributions to the CORE UFO spaceship, engine found in the WOW data. So we were talking about nuclear magnetic resonance to magic angle spinning, mass. Keywords were in a formula that was found in the data from 7B78, magic angle spinning part 3 formula, UFO, and then 7B82, Vespel Diamagnet bendable metals formula UFO is the previous video, and that talks about the exterior of the spaceship, making it bend and move as it travels. July 1st, my thoughts. The keyword magic angle spinning has several videos and formulas with it. The data was from June 29th research date. Today's July 8th. Google potentious fluid from data in part 2. So it was in the part 2 video because I didn't know what it meant. From a magic angle spinning titled 7B77 magic angle spinning part 2 formula UFO. Okay. P2, I put P2 instead of part 2. Okay. So the keyword is a water signal suppression to 3 selective radio frequency pulses. So we're going to Google the keywords 3 selective radio frequency pulses. Okay, I already got that listed there. Don't need that. There's a PDF file quote from the blog, continues in this video. The keywords from the data are advanced 3-dimensional tailored RF pulse design and volume selective parallel excitation. There's the name of the scientist. So the keywords I'm going to Google are TRF pulse, tailored frequency RF. Quotes from PDF results found on a blog, Journal of Physics, Pierre Alexandre Delattre from, doesn't say what year. Radio frequency capacitively coupled plasmas excited by tailored voltage waveform comparison of experiment and particle and cell simulations. Usually if it's a PDF file, I can't get the information, so then I just don't touch it, and I just put the link up there for you. That's from m.iopscience.iop.org. Paper. Okay, no, this one did come up. Okay, so using a range of different diagnostics, we have performed a detailed experimental characterization of a capacitively coupled RF plasma discharge excited by tailored voltage waveforms in argon, 3 to 13 Pa. So argon is one of the keywords, argon gas, right? So this came up and I thought, oh, okay, let's take a look at this. The applied pulse type tailored waveform consists of between 1 and 5 harmonics with a fundamental of 15 megahertz and are used to generate an electrically asymmetric plasma response manifested by the formation of a strong DC bias in the geometrically symmetric reactor used. Experimental measurements of the DC bias, electron density, ion current density, ion flux energy distributions at the electrodes and discharge current waveforms are compared with a one-dimensional particle and cell simulation for the same operating conditions. The experimental and simulation results are found to be in good agreement over the range of parameters investigated and demonstrate a number of unique features present with pulse-type tailored waveforms, including increased plasma density and ion flux with the number of harmonics and a broader control range of the ion bombarding energy. So the PACs are high frequency and RF discharges, electric and magnetic measurements, electron collisions, plasma sources. And, ooh, it's a brand new one. This is from May 2013. iopscience.iop.org. July 6th. Formula from the data. Capacitive coupled RF plasma discharge excited tailored voltage waveforms, argon, 3 to 13 Pa. Applied pulse type tailored waveforms, 1 to 5 harmonics, 15 megahertz, generate electrically asymmetric plasma response, formation, strong DC bias, geometric symmetric reactor used. Experimental measurements, DC bias, electron density, ion current density, ion flux, energy distributions, electrodes, discharge current, waveforms. Compare dome, dimensional particle and cell simulations, same operating conditions, experimental simulation, results, agreement, range parameters, investigated, demonstrate, number, unique features present, pulse type Taylor waveforms, including increased plasma density, ion flux number, harmonics, broader control range, ion bombarding energy, high frequency RF discharges, electric magnetic measurements, electron collisions, plasma sources, plasma physics, liquid argon gas, colliding neutrinos, ions. The polymers will continue in the next videos from the previous data. Thank you for watching.